Hi, welcome to MongoDB Live and welcome to my talk. A little bit before we begin, when I say at scale, I don't mean we'll be talking about how to scale up your application, but rather how you troubleshoot performance problems that are happening at scale. Because it can feel like everything is running fine and then performance problems come out of nowhere and take down your application. And of course, this isn't truly what's happening, but it's really easy to feel that way. So we're just going to talk about the workflow and some tips and tricks that our team uses to keep our application running efficiently and to solve these performance problems as quickly as we can. So wherever you're at with MongoDB, I hope that you can pick up on a couple of useful, actionable takeaways from this talk. So let's get started. I've been working at MongoDB for about 2 years now, and I primarily work on our internal tool, Evergreen. So Evergreen is a continuous integration tool. It uses multi-platform cloud computing to run tests. So this means that we store user data, host data, build variant data, test logs, and all of this combined, we have over a petabyte of data with 10,000 queries per second. So we aren't merely using MongoDB to dog food the product. We are actually using MongoDB in a really meaningful way. So this is what the homepage for our application looks like on a given day, any given day. So each of those columns is some code change that an engineer has made, and each row is a different variant that we're running tests on. And so then each of those little boxes that you see represents a set of tests and where they are in their testing. So if the box is gray, that means they've yet to run. Yellow means that they're in progress, and then green and red represent succeeded or failed. So just loading this page requires loading a lot of information to figure out where each of those tests are in their progress. So it's not uncommon to see this information loading for a little bit of time, but if we're stuck on this page and our users can't figure out what's going on with their tests, what do? So when you first start troubleshooting performance problems, it can be really overwhelming, and you can feel a lot like Lego guy on the left, who has a lot of things open, but maybe doesn't know what to look at and feels really overwhelmed, and there's a lot of pressure. And so I'm hoping that after we talk a bit about the tools that you have and how to use them and how to get started, you'll feel a little bit more like Lego guy on the right, who has some experience and knows what he's doing with his tools and has the support he needs to succeed. So what does the workflow for Lego Man number 2 look like? So we have a symptom that indicates the problem. Our application isn't loading, and we'll come back to this throughout the talk as an example. You want to determine if the problem is your database configuration rather than a logic bug with how your application is using the database. You want to handle the immediate problem if you can, so by mitigating the symptom that your users are seeing. And then if you can, you want to propose a long-term solution. So we're going to be focusing on cloud metrics and MongoDB Shell and how you can use these tools to figure out what's going on with your performance problem. And then we're going to touch briefly on how the drivers can help you with application performance management, which is just the monitoring of performance and availability of your application from the client side. So starting with cloud metrics, this is a really powerful tool because visualization is really great and it's helpful to see what's going on just by looking at it. But there are a lot of graphs. So if you're looking at each and every one of these metrics that MongoDB gives you, it can be kind of overwhelming to know which one is helpful for you in this moment. So for performance problems, we're really just going to focus today on operation execution time and tickets available. So tickets available refers to the read and write tickets that control concurrency in WiredTiger, which is MongoDB's storage engine. So they control how many read and write operations can execute at the same time. So WiredTiger has 128 read tickets and 128 write tickets. And you can see here that there are two lines. The green line is for writes and the blue line is for reads. And they're at about the same pace. We show a lot of tickets available. Now, it's not uncommon for this to spike occasionally, but you don't want to see this ever drop really low. So on the day that our application wasn't loading, we saw this happen with tickets. Our read tickets dropped down to 0 available tickets and stayed there. So that indicated that there were probably some really long-running, slow queries that had taken a ticket and were just holding on to them. So what were we going to do in this situation? Another thing I want to mention, I don't think that queues is as dynamic and powerful as tickets available, but it is interesting that around the same time that tickets drop to 0, you can see that the read queue goes all the way up. So these two graphs go very well together. And the read queue is the number of operations that are waiting on a ticket. So now that tickets have dropped to 0, the read queue has spiked. So operations are waiting on tickets. Another interesting graph is operation execution times. So this is the average time that an operation takes. So the top line is the write operations and the bottom line is read operations. You would expect read operations to be pretty quick because they don't have to do as much. And write operations have to take at least some amount of time because they need to update indexes and things like that. But for us, writes never go above, say, 20 milliseconds. Now, having high operation execution times isn't necessarily a bad thing. Perhaps your application doesn't do very many writes, but when you do, you make a lot of changes. So your average execution time might be much, much higher than this. But you want to just make sure that you don't deviate too frequently from your norm, besides some spikes that might indicate some heavy write or some unusual migration. And you want to make sure that if your execution times are high, they are infrequent, which is something you can also figure out by looking at tickets available. So if you know what the standard is for your application, you can utilize alerts to keep track of your database without having to check it so frequently. So having alerts on read and write tickets dropping below some number, or having operation execution time, say, go above 50 milliseconds for us, is a really good way to track how your database is doing. And you can configure this so that the alert only sends if the condition has lasted for some amount of time. So if you want to keep occasional spikes from unnecessarily sending alerts, that's a great way to do it. And this does take a little bit of time to fine tune because you don't know exactly yet what threshold is the right amount of alerts. You don't want an alert that's too chatty, but you also don't want an alert that doesn't tell you when something is wrong. So the sooner you can get started on that, the sooner you can begin fine tuning the sensitivity of your alerts. So we know now that in our example, the read tickets are being held by probably some slow running queries. So slow running queries indicate an issue with indexes. So the performance advisor is a great place to start when you suspect indexes because it advises you on indexes you can create. So on the left, you can see the index that it's suggesting you make. And on the right, you can see information about why it's suggesting that index. So execution count is the number of queries executed per hour, which would be improved. Average execution time is the amount of time that the operation is currently taking. An average query time is the ratio of documents scanned to documents returned. So you can see here in this example that the query is really simple. It's just on one field. So we aren't using any information likely in the query to filter the number of documents we're using. So we are searching through every document in the host collection. And Evergreen provisions and terminates on average 35,000 hosts per day. And we can't delete hosts right away in case we need to look at hosts in the past. So our collection has become very large, and so we really rely on indexes. That being said, creating a new index on a very large collection can be more expensive than it's worth. And so it's possible that you can add fields to existing queries to utilize indexes that you already have. So for example, if only certain types of hosts can even have volumes stored in the document, then maybe you can query on those kinds of fields. Or maybe you only want currently running hosts or something like that. Maybe you can add something to your query. Assuming that you do want to create the index, it takes you to this page where the index is pre-populated. I would just suggest building an index via rolling process because a rolling process minimizes the impact on your replica set or sharded cluster by taking down fewer members at once. If you don't see a relevant or new index in Performance Advisor, you might instead see something useful in your real-time data. So perhaps you still have very slow operations, but they're either too new or not yet bad enough to have made it to Performance Advisor. So the real-time data will show you the operations that are the slowest. So the data moves around pretty quickly because it is real-time data, so it wants to keep you informed. So if you want to look deeper into one of these operations, you can click that caret on the right, and it takes you to the stats page where it shows you the amount of time that this operation has been running, whether or not it's utilizing an index. So if that says no, that's a very good indicator that you can at least look further into this operation. And then it also lets you kill the operation from here. So this is definitely something to be careful with. You don't want to kill an operation that your database relies on, but if you know that your application can regenerate the operation or has a good way of handling it being killed, and you've looked into it deep enough that you think you've either found the problem or you want to free up tickets for other operations, then this is a very good way to sort of get that going. Although this only lets you kill one operation at a time. So we can talk more about how to do that quickly in the shell. The last thing I would suggest is finding the query that was changed, just because you don't always want to be knocking down performance problems like this. You want to prevent performance problems from happening in the first place. So somehow an engineer was able to add or modify a query to either no longer use an index or to add a query that should have been indexed at first. So whatever you need to change in your process to try to limit this from happening, this is a good time to do it before the heat of the fire has sort of left the team. So next I want to talk about MongoDB Shell. The big thing we'll talk about is db.currentOp. So what db.currentOp gives you is a list of in-progress operations. And this list can be really long, and it gives you a lot of information. Like what I have here is just one document in this whole list. And it can be hard to sort of sift through if you're not used to looking at db.currentOp. If you have some practice, things will start to stand out to you if they're not shaped the way you'd expect or something like that. But at first, this can be really overwhelming. So I suggest creating a reference sheet with aggregations and current op that are useful for your team. This is good because new engineers can follow along with other engineers who are trying to troubleshoot the problem, and maybe they don't want to bother them, but they do want to learn new things. And then also it keeps you from having to keep track of your curly braces and your parentheses while you're going through a troubleshooting. So these are just a couple that our team has that I wanted to go through just as examples of what you can do with aggregations on current op. So the top aggregation is just groups on namespace. So that's sort of like hottest collections in the metric page. It gives you an idea of where your operations are mostly localized. The next one aggregates current op on the number of seconds running. So here we have greater than 10 seconds, and that's a very long time. So depending on what you're actually looking for, and again, how your application is, you may want to fine tune that for your own needs. And then the last aggregation is the same as the previous, but we also kill all of these long-running operations. So this is what I was referencing when we were talking about kill op in on the real data page in metrics. So this is really powerful, and it's something you only want to do if you feel confident that killing these operations will be okay. But if you have already started a long-term solution, so say you've started building an index or something like that, and you just want to mitigate the symptoms for your users and sort of get things going, you could just kill all the operations that are taking too long and start to get other things going in the system. So it's a very powerful way to just keep things moving. And these aggregations don't have to be limited to current op. So if there are things with your other collections likely to break for you, then those are also very helpful aggregations to keep in your reference sheet. So for example, we keep our jobs in our MongoDB database. So sometimes jobs can also become stale. And so these same aggregations running on our jobs can be very useful. Lastly, I want to touch briefly on application performance management with the drivers. So what is application performance management? It's generally agreed that there are 5 components to this. There's general analytics, end user experience monitoring, relationships between components on your application, and then component deep dive monitoring and user-defined transaction profiling. So your driver is really just a component of your application. And so by using the driver's command monitoring, you're able to do this component deep dive monitoring and see how your driver fits in with your larger application. So what is command monitoring? I think it'll be easiest to sort of show how easy it is to get going with this as way of example. So you have these two structs. I'm using Go just because Evergreen is in Go. So you have the command started has some basic metadata, and then command finish has similar metadata, but also the duration of the command and things like that. And so what you want to create is this command monitor struct. So it's got this started, succeeded, and failed functions. And you can just do anything in that function that you want with the event that you're passed. So succeeded and failed are just wrappers of the command finished event. And so, for example, I have here, you can increment successes by command type and increment failures by command type. And even though the metadata seems like it may be kind of simple, when you plug it in with the rest of your application, it can paint a larger picture of what's going on at any given time. So then when you set up your MongoDB client, you just add this set monitor as an option. And then every time an operation starts or finishes, it'll call the functions that you've defined in your command monitor. So you can either send the metadata to your third-party application performance management library, or you can send it to some internal logging to keep track of what's going on internally. So for us, we send our logs to Splunk so that we can create visualizations to see what's happening. And so this is an example of some of the visualizations we've made using the driver's command monitoring. So in the top right, you can see succeeded by operation and failed by operation. So it's really as simple as just incrementing a counter, and it's very easy to get started with. So if you're feeling data-driven, feel like going above and beyond, it's really nice to know what's going on the client side. So I hope that going through these tools have given you some ideas of action items or things you can add to your workflow or your process to improve your troubleshooting for performance problems. So whether it's adding some alerts to the metrics page if you haven't yet, the sooner you get started, the sooner you can start fine-tuning the sensitivity of those and figuring out who's the right person to send those alerts to. And then with the shell, creating those aggregations, making that reference page, it's really useful for onboarding new hires and then also just not having to worry about things during crunch time. So thank you for coming to this talk. I hope that you get out there, improve your process, and if you have any questions, please come to my office hours. Thank you.